It is often convenient to use a central value to summarize a set of data. People frequently use a simple arithmetic average for this purpose. However, we're going to consider different methods of determining this, where data tends to cluster. And so we're going to review the mean, median, and mode, and other measures or other ways of calculating measures of central tendency. Now, quick review on the mean. And recall that the mean is just the sum. Now, this is the mean of a population, which is given the variable mu. And so what this notation means is you're adding up all the values for whatever variable you're looking at within the population. So you start with the first and you go up to the nth, where n is the number of units in that population, or the normal of individual measurements in that population. And we can more simply state this as the sum of all the x values divided by the number in the population. Now, we could also do the same thing for a sample from a population, and this more or less means the same thing. X bar refers to the mean of a sample, and so again, this is the sum of all the values taken from our sample divided by the number in the sample. And more simply, more commonly, it's stated this way. So the mean of a sample is the sum of all the values divided by the number of the sample. Now, the Greek letter sigma indicates that all of the individual values of x1 from I equals 1, which is the first measurement in the population, or the first measurement in the sample, up to n, are all added together, and this sum is divided by the number of values, or the number of measurements in the set, or that would be the population or the sample. Now, in this case, to calculate the mean of a set of values of a population, we have here 5 values, and so what we're going to do is, to calculate the mean of the population, we add up or take the sum of all of the values and divide it by the number in that population, which is 5. And so the mean of this population would be 16.2. Now, to review how you find the median is the halfway point of a data set arranged in an array. So if you take your data and arrange it from lowest value up to largest value, the halfway, the middle value, will be your median. So if we take an example where monthly rents are compared in downtown and in the suburbs, and they're classified from a classified section of a newspaper, we want to calculate then the median rent in each district. So if you're given these values, the first thing you should do is arrange them from lowest to greatest. And since we have in this for the rents downtown, we have a total of 7 elements, or 7 data values. The median is going to be the 4th element. And the reason for that is we've got 3 below and 3 above. So the median value will be our 4th element, which is $1,000. So our median rent for downtown is $1,000. So this is quite simple for when you have an odd number of values. Now, in the case of the suburbs, we have 8 values. So in this case, what we have to do is order them again. And so since it has 8 elements, the median is halfway between the 4th and 5th elements. So in this case, halfway between 585 and 565. Because again, we have 3 values below the 2 that we're looking at for our central value, and then 3 above. So we take basically the average of the 4th and 5th element, and so when we add them together and divide by 2, we get a value of $605 per month as our median. Now, the mode is the most frequent value or range of values in a data set, and it is easy to determine the mode from a histogram, as it's always the highest column. So if we take a look at the value of coins in a collection. And you can easily see that this would represent the modal interval where it's between $4 and $5. Now, if there are 2 or more measurements that occur most often, the data is said to be bimodal, or it could be trimodal if there's 3 equally common values, or another term is multimodal. If no measurement is repeated, then the data set has no mode. So it is possible that you will have no mode in a given set of data. Now, analyzing qualitative data. So if you've got a graph where you ask Ontario youths whether or not they have a lot of friends, and ask which measure of central tendency can be used to represent this data. Well, in this case, the mode is the only appropriate measure of central tendency. And it is usually best for qualitative data. And in fact, it's really the only one that you should be using for qualitative data. And so the mode here would be true, because most of the Ontario youths said that they had a lot of friends. The median and the mean depend on quantitative data that can't be measured numerically in this case. So it's not meaningful to calculate the mean or the median of this data, because again, this would be more or less a qualitative data. So we don't want to use mean and median for that kind of variable. Now, if we look at distributions and central tendency, now if we compare the following data sets, and we want to look at what's the relationship between the shape of the distribution and the mean, median, and mode. Now, here we have a uniform distribution. We have a spread of symmetrical spread of our data here. And you can see that the mean, median, and mode are all at the same value, that they're all in the same spot. Now, if we have a skew, so if we have the data skewed to the right here, then this is going to affect where the mean, median, and mode lie. Now, when you look at this graph, it's easier to see where the mode is because it's going to be the most common value in your histogram. But the mean, median, and mode in part B here is skewed to the right, so that the mode, which I said is the most common, is here. The median, the middle value, will be a little bit to the right along here, and the mean will be even further from the 2 to the right. So anytime it's skewed right. If the data was skewed the other way, to the left, then you would see the mean would be the lowest value, and the median would be in the middle of the 2, and the mode would be the greatest value. Now, outliers affect mean more than they do median and mode. So in this case here, the outliers are the higher scores. And so what happens is the mode is not really all that affected by the skewing of the data. However, the mean gives the appearance of a higher value for central tendency than the mode or the median. In addition, notice that the median is typically between the mean and the mode for non-symmetrical distributions. Now, the question is, what measure of central tendency should you use when looking at data? While there is no single rule governing which measure of central tendency you should use to describe a set of data, you should take the following into consideration when you do. First of all, outliers will affect the mean the most. If the data contains outliers, use the median to avoid misrepresenting the data. If the data are strongly skewed, the median might be the best measure of central tendency. If the data is roughly symmetric, the mean and the median will be close, so either would be appropriate. And if the data are not numeric, for example, color or if the frequency of the data is more important than the value. For example, if you're ordering shoes at a shoe store, then the mode would be the better measurement of central tendency. Now, what I want you to do is determine the central tendency of each of the following 3 months here. So for January, I want you to calculate the mean, median, and mode. February, same thing, and March. And determine which is the most appropriate measure to use for determining the central tendency of the data for each month.